As we get into proportional reasoning and working with proportions, we're going to do a method called cross multiplication to either prove two ratios are indeed equal, or to solve for a missing part, to solve a problem involving proportions. We'll be doing cross multiplication. This very short video is hopefully an explanation to tell you why it works. So we will begin with two ratios set equal to one another, and we're using letters just to refer to any number that might exist. It's a little bit of pre-algebra, so to speak, but it'll help us show why the technique works. So what we're going to do is use the premise that whatever we do to one side of the equal sign we have to do to the other. That keeps things in balance. So I want to get rid of the b that's in the denominator here. So I know that if I multiply this side by b, then b over 1, then I'm going to eliminate the b in the denominator. I'll show you why in just a second. But it's important to know that if I do that over here, I have to do it over here. The equal sign says keep me balanced. Well, following this math, we'll just do multiplication. B times a, well, we don't know what those numbers are, but we know that whatever they are just b and a multiplied together. And 1 times b is b. And I know that c times b would be c times b, and d times 1 would be d. A little math here will tell me that any number over itself would be 1, so that reduces down to 1. So I'm left, after multiplying both sides with b, with the equation a equals c times b over d. Now, perhaps you see where we're going with this now, because let's do what's necessary to get rid of d in the denominator over here. Well, as in the previous case, I'm going to multiply by a fraction. I'm going to call d over 1. Now I'm using d over 1 just to equate that to the multiplication you've already done with fractions. And again, so I have to do that on this side. If I'm going to keep the equation in balance, I must do that over here. Now, let's do some math. D times a, and remember that any whole number is itself over 1, so we'll just put that there to clarify that. So d times a is equal to, well, I don't know what the numbers are, but I know that it will be d times a, and over 1, I'm going to just write that. We'll follow along. And then c times b times d. I don't know what those numbers are, but I know that whatever they are, they will be the multiplication of all three digits. Well, then d times 1 is d. Well, again, earlier I know that any number over itself is going to reduce down to 1. So that leaves me with d over a, d times a over 1, which I'll just write like this and drop the denominator of 1 equals c times b. So now, taking this, we can, by the process of the commutative property of multiplication, know that a times d is equal to d times a. So I'm left with this truth just by doing this little algebra. Well, it's not as important that you're able to do this right now in 8th grade, although you will get there. But what I want you to see is it's not magic. When I look at my ratios, that a times d is equal to b times c. So let's see how that helps us test a couple of things. What if I want to prove that 2 over 3 is indeed equal to 12 over 18? Well, very quick look at the math says a times d, well that's 2 times 18, should be equal to 3 times 12. Well, let's see if it is. 2 times 18 is 36. And is that equal to 3 times 12? 3 times 12 is 36. So, yes, 2 over 3 is equal to 12 over 18. Well, while we've got a couple of minutes, let's just solve a problem as it would exist. Suppose you have a ratio of 2 to 3. It could be 2 cups of sugar to 3 cups of flour, or 2 cups of concentrate to 3 cups of water. And you know that you now want to create a mixture that instead of, well, just use 3 cups of water, you have 18 cups of water. And this is my concentrate of whatever. Well, I know that if it's ratioed, if the recipe, if standard convention says there's a 2 to 3 ratio, then that has to be the same even if I make it with 18 cups of water. So that means that this number, and I'll put a question mark up there, has to be in balance, have to be equal. Well, let's use our cross multiplication rule. I know that 2 times 18, I guess I'm stuck on 36 this morning, has to be equal to 3 times, and I'm putting a question mark there. A little bit later in algebra, you'll replace it with an X or a Y, but I just want you to see it's an unknown. Well, 2 times 18 is 36, and 3 times question mark, we don't know what that is. We have to ask ourselves, what times 3 is equal to 36? Well, I hope by now you've recognized that as a division problem. So I'm going to divide both sides by 3. And there we go again. Any number divided by itself reduces down to 1. So now I'm left with one question mark, if you will, which is good because I can only answer one question at a time, is equal to 36 times 3. Well, a little quick math on the side. Let's see, 36 divided by 3. 3 will go into 3 one time, and that will leave nothing there. Bring down my 6. 3 will go into 6 twice. Yes. So the question mark, the unknown here, is 12. Well, to put it in the context of the question, if I'm making a recipe of lemonade that's 2 cups of concentrate to 3 cups of water, and I want to make a bigger batch where I use 18 cups of water, then I have to use 12 cups of concentrate. It's all about ratios, comparing of part to part. It's all about keeping those ratios in balance, which we call proportions. I hope this helps you understand a little bit about how cross multiplication works, and then how to apply that to either test a fraction as being indeed accurate and equal, or to solve for an unknown. Thank you. As we get into proportional reasoning and working with proportions, we're going to do a method called cross multiplication to either prove 2 ratios are indeed equal, or to solve for a missing part, to solve a problem involving proportions. We'll be doing cross multiplication. This very short video is hopefully an explanation to tell you why it works. So we will begin with 2 ratios set equal to one another, and we're using letters just to refer to any number that might exist. It's a little bit of pre-algebra, so to speak, but it'll help us show why the